Okay, so this is the notes for 1-2, talking about measuring segments. Don't forget to write down the section title right now so that you can get that 1 point for this section. We're going to be focusing right now on the main definitions. I'm not going to really be doing any examples with you, any complicated ones, because we're going to do that in class together. But right now I just want you to see the basics before you come to class tomorrow. So congruent means equal. We talked about that earlier. Congruent segments are segments that are equal. In other words, they have the same length. They are not, they can be flipped around, going forwards or backwards, but they both have to have the same length. Like AB is 10 centimeters and CD is 10 centimeters. That means that AB is congruent to CD. And to show that, we can put a little matching little dash there. AB has one dash, so anything that's congruent to it will have the same dash. And I'll show you more of that later. The symbol we use for the word congruent is an equal sign with the squiggly part on top. That means congruent, where you're talking about two segments or two items that are actually equal or the same length. So how you write it is that segment AB, and remember it's a segment, so we don't put any arrows, just a segment mark. And we put the congruent sign. AB is congruent to, is the same length as CD. A segment with no arrows, just two endpoints. One main word you need to be aware of is the word between. I know you've heard that before, but in geometry it means something very specific. It means that anything that's between 2 points has to be on the same line as them. A, B, and C are collinear. Remember, collinear means they're on the same line. So if you have 3 points that are on the same line, and it doesn't matter what the line looks like, if point B is between A and C, here's point B, and it's between A and C. That's the only way it can be between, is if it falls on the same line. If point B is in between the space here, but it's up here or down here, it doesn't count as between. It has to be on a straight line. The segment addition postulate is one of the most important things we're going to be doing, and you saw it earlier in class today, but let's write it out officially now. If B is between A and C, just like we have up here, if you have 2 or 3 points that are in the same line, and B is between them, means that B is in the space between them, but also forming a straight line. So if we have endpoints A and C, we make these bigger so they look like they're on the same line. B is between them, and it doesn't have to be exactly the middle. It's just somewhere between the two as long as it falls on the same segment. Then what we've created here is 3 separate segments. See if in your mind if you can see them. Obviously, there's segment AC. And that's in blue, segment AC. But try to picture in your mind the other 2 segments that are on the inside. One of them is the shortest one right here, segment AB. That's a segment by itself, even though it's part of this whole diagram. AB. And the other segment that's there, can you see it? Do it in green. It's from B to C. There's technically 3 segments there that all come together. Now think about which 2 could be added together. Segment addition means you're adding segments. It's the 2 smaller ones. The red one, AB, plus the other segment on the inside, BC. The 2 segments on the inside equals the longer segment on the outside. AB plus BC equals AC, and that's called the segment addition postulate. So to use it, let's do a couple simple examples here. Suppose that S is between A and B. So we have to have a segment here, and the endpoints are A and B, because S has to be between them. So here's A, and here's B. S is somewhere between them, and it doesn't matter where. It's just a sketch drawing. It's not a perfect diagram yet. Now we just take what they gave us. If it's true that AS equals 5, so I'm going to put 5 right here for AS, And SB here is equal to 8.1. Go to the diagram and put 8.1 under segment SB. Here's segment SB, so I'm going to put 8.1. Now read the question. The question is to find AB, so you have to find that segment in the picture. It starts at A and it goes all the way to B. So to figure out what AB would be, all you do is you add these two segments together. This one we can do in our head. 5 plus 8 is 13 plus 0.1. So AB equals 13.1. All right, but it's not always that easy. You have to draw the diagram in order to figure out exactly what you're supposed to do. So for this next one, it says that S is still between A and B. So draw a different diagram. A and B are the endpoints. Here's A, here's B, and S is between them. So S can be anywhere. It doesn't have to be the exact middle. Put in your given information. This time it's different. AB, oops, wrong one. AB is 16.3. That's from A all the way to B. So go from A all the way to B. The whole segment is 16.3. And go back to what we're given. And another piece of information is that from A to S, segment AS is 2.4. So from A to S, it's 2.4 right in here. And the question is find SB. SB is this little piece left over right here. They want us to find SB right here. So think about it. We're not going to add these two pieces together because 16.3 is the longest piece. How would I find the missing piece here? You would subtract. So want to make sure I don't make any mistakes. So I'm going to get the the calculator out, and I'm going to do 16.3 minus 2.4. And you end up with 13.9. So the answer to the question, SB, is 13.9. All right, and if you have any further questions on that, make sure you just write them down to the side or something so that I can answer those questions for you tomorrow. Just as you're doing things like this, make sure that you find out what the two endpoints are and put the letter between somewhere on the inside of those two segments. Turn the page, and let's just do a couple more of these so that you'll be ready for tomorrow. Midpoint is basically just what it sounds like. I know you already looked at the vocab words and you highlighted the important words for midpoint. The midpoint is anything, a ray, a line, or a point, or anything that divides the segment into two congruent segments. So the key to being a midpoint is that it's right in the middle. It cuts the segment in half. That means equally. Both halves that you make are equal to each other. So if P is the midpoint here, in this figure, P is the midpoint of segment NQ. If P is the midpoint, that means that this half right here is exactly equal to this half right here. That's the key to being a midpoint. It cuts it exactly in half. If I do my congruent markings, this piece and P is exactly equal to this piece because P is the midpoint. Another way we can say it is that NP is congruent to, think about it, if NP is one half, what's the other half that's going to be the exact same? Hopefully you thought to yourself that the answer is PQ. Those two halves are exactly the same. And now let's just write an equation so that we can solve. 1/2 is 3x. I'm going to put that right here. 3x is equal to, think about what the other half is. 3x is equal to the other half, 2x plus 4. And a lot of this, once you think about what the main word is, midpoint, what it means, it cuts in half, you can pretty much just see exactly what you need to do from there, that this side equals this side. So we have 3x, subtract 2x from both sides, you get 1x equals 4. Sometimes the problems will go back and ask you to solve for each individual one. So let's do that. X equals 4. If we use 4 right here, what we're saying is that it's 3 times 4. Substitute the letter x with the number 4. So for this side, we have 12. This side has to be 12 also because the two are equal. But let's prove it by plugging in. 2 times 4 is 8, plus another 4 is 12. So you have it right there. Now think for a second. If NP is 12 and PQ is 12, tell me what the whole segment NQ would be. Go ahead, just say it out loud wherever you are. Just joking. If you're in the library, don't say it loud. NQ is 24. Okay, and we will definitely be practicing this a lot tomorrow. I just want you to be aware of it before you come to class. This is not the only practice you're going to get. It's just an introduction to it. And the last two things is just this part. Bisecting means divide equally, whether it's an angle bisector or a segment bisector or anything in geometry. From now on, you can bisect a rectangle. You just have to know that that means cutting it equally. You have two equal parts. So let's just write out this one really quickly. A segment bisector is any ray, segment, or line, any object that intersects a segment at the midpoint. Why in the midpoint? Because that's halfway. And a bisector cuts in half. Any kind of a bisector will always cut it in half equally. Okay, so just for a quick example, draw this right here. These are the two endpoints. If you have a midpoint right here in the middle, if this is the midpoint, then this segment right here is cut equally in half. This one has 2 marks, so the equal part has to have matching 2 marks. These two are exactly the same. The two halves are the same. All right, and that's it for today. Tomorrow we're going to be practicing and having an assignment that you'll hopefully finish in class tomorrow. All right, thank you. See you tomorrow.